Hello, calculus fans. Okay, so let's try to evaluate now the cotangent of the inverse cosine of 2/5. Again, this is not a calculus problem. It's just a way of us reviewing a little bit about inverse trig functions. Now, we haven't specifically talked about the inverse cosine function, but you would develop it in much the same way as you would the inverse sine function by restricting the domain of the cosine function in an appropriate way. And you would then, if you did so, you would restrict the domain to be between 0 and pi. And the book shows some of the details of how this works. But we just want to focus on evaluating this expression. We can do that without knowing a whole lot about the inverse cosine function. So the way we'll set this up is we'll let theta be equal to that unknown angle. So remember that the inverse cosine of a real number is an angle, is how we should be thinking about it. So if theta is inverse cosine of 2/5, that means cosine theta is equal to 2/5. Well, let's draw a triangle showing that. So here's a triangle where we marked theta and we have the adjacent over hypotenuse, so katoa. So we have our adjacent side is 2, our hypotenuse is 5. We're interested in knowing the value of the cotangent of arc cosine of 2/5. And remember, we called arc cosine of 2/5 theta, so this thing is just cotangent of theta. So now we can ignore this arc cosine and we can just look at our picture and say, from this picture, we want to know what's cotangent of theta. And so that means there's a side here that we don't know about. We need to figure out what's the length of that side. So here's the picture again, but now we've got a variable in there for the missing side. And let's calculate what that missing side is. So that's actually not that hard. You just use the Pythagorean theorem. 2 squared plus w squared is equal to 5 squared. And if you solve for w, you'll get square root of 21. Okay, so that's no big deal. All right, so now we know the length of that missing side, square root of 21. And so we need to know what cotangent of theta is. So that's pretty straightforward. So we're computing cotangent of arc cosine of 2/5. That's cotangent of theta. Tangent of theta is opposite over adjacent. So cotangent theta is adjacent over opposite. So 2 over square root of 21. And that's going to be our answer. No need to simplify any further. For instance, there's really no need to rationalize the denominator. Probably at some point in your life you were drilled home the need to rationalize denominators. I think that's terribly overrated. That's all for now.